Welcome to our second discussion about matrices. So, our topic for today is about matrix operation. To start, um, let's define first equality of matrices. So, two matrices are said to be equal only when all corresponding elements are equal. So, two matrices are equal if the corresponding elements of that two matrices are equal. So therefore, the size and the dimensions of that two matrices should also be equal. So let's consider matrix A and matrix B. It is these two matrices are considered equal because all the elements Aij of matrix A and Aij of matrix B is equal, and all goes to all the elements of A and elements of B. So these two elements are called equal matrices. So there's properties of matrices that we should consider. If and only if matrix A is equals to B, then matrix B is equals to A for all A and for all elements of A and B. Second, if and only if matrix A is equal to matrix B and matrix B is equal to matrix C, then matrix A and C, matrix A is equal to matrix C for all elements of matrix A, B, and C. So therefore, Aij of A, Bij of matrix B, and if you have Cij of matrix C are all equal. Addition and subtraction of matrices. So the sum or differences of two matrices, matrix A and matrix B of the same size yields a matrix C of the same size. So the columns of the rows and columns of matrix A, Aij, and Bij should yield to the same size of matrix C. So matrices of different sizes cannot be added or subtracted. Take note on that. So there is a cumulative law about matrix operations. So when matrix A plus matrix B is equal to matrix B plus matrix A. And also the associative law, which is, I think you are all familiar with. Matrix A plus open parentheses of matrix B plus matrix C close parentheses is equals to open parentheses matrix A plus matrix B close parentheses plus matrix C is equals to matrix A plus matrix B plus matrix C. That is if all your matrices, if your matrix A, matrix B, and C are of the same size and dimensions. In this example, your matrix A is a 2 by 3 matrix, while your matrix B is the same, and of course, your sum or your difference is of the same size, 2 by 3. So let's take for an example, 7 matrix A plus matrix B is equal to matrix C. So the element Aij, the element A1, 1, 7 is added to the element in B11. A11 plus B11, A12 plus B12. So 7 plus 1 of 8, 3 plus 5, you have 8. Then negative 1 plus 6, you have 5. And all goes to the remaining elements of matrix A and matrix B. So, next is adding a null matrix. Matrix A plus 0 matrix is equals to your null matrix or 0 matrix plus A is equals to A. Also, if you add matrix A plus the negative of matrix A is equals to 0, where negative A is the matrix composed of negative A, ij as elements. So in this example, we have the difference between matrix A and matrix B. We have element Aij minus the Bij. So 6 minus 1, you have 5. 4 minus 2, you have 2. And 2 minus 2, you have 0. So this is just an example of a subtraction of matrices of the same size and dimension. Next topic is about scalar multiplication of matrices. So matrices can be multiplied by a scalar quantity. A scalar, or it is a constant or a single element. So let k be a scalar quantity. Then k multiplied by matrix A is equals to A times the k as a scalar quantity. So if the value of k is 4 and we have a matrix of dimension 1, 2, 3, 4. 4 by how many rows? 4 rows and 2 columns. 4 by 2. So we have k as 4, then matrix A with 4 by 2 dimension. So the result will be this one. You only have to multiply the scalar quantity or the scalar value into each element inside the matrix. So we have 4 times 3, of course, we have 12. 4 times 2, 8. 4 times. This is equal or the same when you place the scalar value for here in the right side of the equation. So it's the same as stated in the previous procedure. So there are other properties of multiplication of scalar quantities in the matrix. So you have when you multiply the scalar quantity k to the sum of matrix A plus matrix B, it is equal to, you distribute the scalar k to each matrix. So k matrix A plus k matrix B. And when you have a constant g, so you have k multiplied by matrix A plus g multiplied by matrix A. Okay, multiplication of matrices.